Thank you. So, as you know, all of you, Nick Rice, Regional Manager of First 5 Minutes, for those you don't know. And what we're going to talk about today is smoke management systems. Smoke management systems is absolutely massive. It's a huge, huge subject. So I'm really only going to cover the basics of it. But I'm going to recap you on untenable conditions and flashover because they both take a big part in managing smoke in buildings. And there's factors that influence smoke, which I've spoken about earlier on in these sessions. There's many options to manage smoke. So we've got things like powered systems, we've got pressurization systems, and there's also compartmentation. So if you remember the untenable conditions, just briefly, I've put it all up there, but you've got the toxicity of smoke, the temperature of smoke, radiant heat, and the smoke layers, if it's greater than 2.1 meters above the floor level and greater than 200 degrees C, or when the smoke layer is lower than 2.1 meters and is more than 60 degrees C. Now that is for an average person in a building. That's for people like you and I. The fire service have other tenable conditions, which obviously are a lot lower than that because they've got their firefighting gear. And flashover, if you remember, that is what we call a fuel control fire, when you've got an excess of air coming in. So you've got loads of air coming in, feeding the fire. You get the temperature of the smoke up to around about 600 degrees C, bang, flashover occurs in the room. And that's what smoke management systems try and do. They keep tenable levels, so keep the smoke layer level height above the 2.1 meters, and obviously keep the temperature down, and prevent flashover happening. So they don't want to build up the smoke and getting that 600 degrees C. You could have 500 people in a room and they just flash over and it will just do everybody. So smoke. So design smoke management systems, we've got to, as I said, got to maintain the smoke layer level, and we've got to maintain the temperature. And smoke is a product of where the fire is in the room. And if you remember on earlier sessions, I said if you have a fire against the wall, you've got the flames probably about 75% higher than it was in the center of the room. It's the same with the amount of smoke being produced. So where the smoke is, where the fire is in the room, depends on how much smoke is produced. And also you've got to have a look at what is the materials burning in that room as well. There's a hell of a lot of factors go into it. So what they do with the flow rate, the smoke is in a flume, it's worked out the volumetric flow rate described in meters cubed per second, or the mass flow rate in kilograms per second. And there's many, many equations to work it out. Smoke travels at around about 2 meters per second, which is around about 7 kilometers faster than average human. Average human walks around about 1 meter a second. So you can see there's a lot of factors to be taken into there. And if you have a look, I was going to put one on, but there's huge equations for, you know, what type of material is burning, where it's going to be burning, what the openings in the room, how much air is coming in, all that type of stuff. And then they have to work out volumetric flow rate, and then they work out the extraction system or the containment systems they put into those into the rooms. So there's many options to do that. And you've got smoke dilution systems. So you've got systems that extract the smoke and extract the heat out. You've got pressurization systems. You've got natural ventilation systems. There's sprinklers as well. Remember we spoke about sprinklers. Sprinklers can kill a fire. They also take a part in cooling the smoke layer level down as well. And if you think about it, what we've been on about so far with smoke detectors, thermal detectors, barriers, compartmentation, fire doors, firewalls, all that type of thing. All these passive and active systems work together. So if you've got a detector go off, it can close the door, which causes a compartment. It can start smoke extraction systems or pressurization systems up as well at the same time. It can start up building management systems. It calls a fire service. Just one detector going off does a whole array of things, which we will explain later on in other sessions when we go into fire indicator panels and things. Then you've got containment systems, you've got smoke baffles, you've got curtains. You might not see curtains in shopping malls and offices. They're normally rolled up inside the ceiling, alarm goes off and these curtains come down, normally over stairwells and things like that. They're trying to keep, if you've got fire, if you've got an internal stairwell, for example, like we've got a couple in Adelaide, an internal stairwell, which goes up to the next few floors. One of the floors might have a smoke curtain on it. So if there's a fire on the floor underneath, it won't get to the floor on top. And we've got obviously doors and we've got windows. So powered extraction systems then. There's many advantages and disadvantages to these, but they remove the hot toxic gases, avoiding flashover and prevent the smoke spreading. Remember we said smoke was one of the biggest killers in a fire. Kills about 80 to 85% of people, and nowadays there's a lot of toxic gases there. They try and keep the zone into tenable conditions. It gives more time for fire service to intervene, and they can be placed away from where they're going to put the fire design. They can place it away from where the fire could be. So it could be like 50 meters away, connected by ducting, which then stops any wires melting or any the burning of the supply pan things. The disadvantages, there's disadvantages in everything in life, like there's advantages. The location and site of the detector, there's very noisy as well. So they can frighten people. And if you've been in stairwells when an alarm's gone off or when you've done a trial evacuation exercise, they've set the detector off, it gets very noisy. And then there's plug holing effect as well, which I'm going to explain on the next slide. But basically, it's where smoke spins round and round in circles and you take more air out than smoke out of the building. Once the smoke's outside, where's it going to go? It could go down air conditioning ducts. It could go into other buildings. And it requires a lot of maintenance, which is very costly. It's a very important part of the building design, because we've realised over the years it's the smoke which kills people. It's the smoke you've got to get out of the building for the toxicity of it, and trying to keep that temperature right down below the 200 degrees C to keep it tenable conditions. So that's plug holing there. You can see where you've got, it's starting to plug hole. You've got your smoke layer level there, and inside there you can't see it, but more air will be taken out of smoke, and the smoke layer levels falls down below the design height of the fire. When I say design height of the fire, that's an engineering term. Natural ventilation systems, then, they're very cheap. They're permanently opened, or they can open on alarm, and they're very low maintenance. The thing is, do you know where the fire is going to be when they open? Do you know how fast the wind's blowing? Do you know which direction the wind's coming in from? Because it can blow smoke back into the building. But they're very, very cheap to run. And that's a picture from Kizzy Grice, Adam, your cousin, when she was 12 years old, when she actually did a school topic on fire engineering when I was doing my graduate certificate. So she was getting a lot of information from me, and she used to come to training sessions with us as well in the early days, where, you know, when I did weekends in shopping centres and places like that. So that just shows you a natural ventilation system, and that shows you a powered extraction system. These bits here, which I'm going to talk about in a minute, are barriers, smoke barriers. So you can see the smoke in there. Those barriers are designed to stop the smoke going out and just take it into that compartment, so the smoke doesn't flow into that compartment. Excuse me. So barriers and curtains, the advantages and disadvantages. They can divide large spaces at high level, okay? And they can work in conjunction with the smoke extraction systems. The problem is, if you've got a low ceiling height, these barriers are not much good. So if you go in a shopping centre and you see loads of glass things hanging off the ceiling, they're not just to keep cleaners employed, they actually serve a purpose, and you normally find that that's a smoke zone. So theoretically, you could stand, for anyone who's in Adelaide, stand at the top of the escalator at the cinema end, look right down the mall towards Coles, you can see all these barriers. If there was a fire in one of those zones, technically you don't have to evacuate, because a fire should be contained, if it's been engineered right, within that zone. So if you have a look at big shopping centres, you guys, when you go around, have a look for smoke barriers there, and you can say, oh, that's the zone there. If there's a fire in that zone next door, theoretically, it shouldn't come into your zone, which gives people more time to evacuate. So stair pressurization systems, they call them stair pressurization systems because they allow the stair pressure in there to get higher than the surrounding areas. But what they're actually designed to do is to create airflow. So if you've got airflow, if you open the door, and if anyone again has been in a building and they try and open the door when a fire alarm's gone off or when you're doing a trial evacuation, and it's quite hard to open into a stairwell, that's because of the fans that go in there. The fans are on. So the way to do it is not go and bang it with your shoulder and that, push down on the handle and bang it on the shoulder, because as soon as you break that seal, you're going to fly the door right open and you could go into a load of people who are evacuating. Best thing to do is push down on the handle, put your foot at the bottom of the door and just push your toe, break the seal and open the door carefully, because you know these stairwells, they get quite narrow sometimes, especially nowadays when they're trying to put space in for office space. So the force of a handle shouldn't exceed 100 newtons, which is about 10 kilograms. For doors as well, once they're open and people have gone through it, they should be able to be pushed and latched shut by the airflow, and pressure should be restored within 10 seconds. Noise levels are a factor and should be considered, especially when you're doing training in high-rise buildings. But you say, don't worry about the noise in the stairwell. It does get very noisy. That these fans or these pressurization fans, and in a high-rise building, you might have a fan on the roof, then you might have another fan about 4 or 5 floors down, and then another fan about another 4 or 5 floors down. So quite a few fans going on. So just make sure you know, if you're doing training in buildings, that pressurization fans is quite a natural thing to occur. And don't forget as well, the standard practice for evacuating buildings, high-rise buildings, is the effective floor, 2 above and 1 below. A few reasons for that. One is so you don't get congestion in the stairwell. And if you can imagine all doors opening as well, you're going to get congestion in the stairwell, and all the doors opening, you're going to lose all that pressurization system. So it might not be as effective pushing the smoke onto the floor, like so. So you can see there, Kizzy done another one there. So you've got a fire on the floor there, the door opens, they're evacuating out, and it keeps the smoke out of the stairwell. And if you remember in the early days, I said the importance of keeping fire doors shut and latch shut, very important at all times, because you can imagine if you get a fire on that floor and it gets into that stairwell, it goes up there and makes that stairwell absolutely useless. So you've got to try and direct people to the next one. You see there, hold the handrail only, go single file downstairs on the inside, because hydrants on normal buildings are normally on the outside. So if you've got the fire service coming up, you don't want to be banging into them. Also tell people not to take tea and coffee down there. They can take small bags and things, but not things like suitcases and what have you. The other thing is, when they go to assembly areas, you put there down at the bottom, Kizzy put to the assembly area, not the bean bar, please. That was probably one of my little quicks I used to put in when I used to do training. So compartment, you also get compartment pressurization systems in buildings. They're very hard to control, especially in places like shopping centres. But in buildings, we've got one in Adelaide, which has got compartment pressurization system on the floors, and it's got a whip phone in there, and it's got a two-way swinging door. And what it's designed for is mobility impaired people. So if you've got someone mobility impaired, they can go into this area, and then if they need to be rescued by the fire service, they can come up what they call the preferred lift, which is a goods lift, which isn't a fire rated lift, but it's a preferred lift to use for a fire service, and they can pick people up. But that's not in every building. Some buildings you do see compartments pressurized for mobility impaired people, and you see them for other reasons as well, like keeping people safe generally. But all these smoke management conditions, they've all got various considerations. So you've got asset, that's available safe egress time. So the wrong design can affect asset. Can we guarantee how many people are going to be in that zone at one time? So if you look at a shopping centre, next time you go in a large shopping centre, and you might go on a Wednesday evening just before it shuts, there's hardly anyone there. But if you go on a Wednesday evening, if it's Christmas Eve, there's going to be thousands and thousands and thousands of people there. So can we guarantee how many people are going to be in that zone at one time? Is everyone going to be traveling at around about 2.2 to 2.5 meters per second? The assumption is that you might have 20% mobility impaired people. Doesn't mean people in wheelchairs and things. That could be people walking sticks. It could be people who've been injured with football injuries. It could be old age pensioners and things. Can we assume that, yeah, are all the smoke management systems working correctly? They've got to be maintained and working. If they're not maintained, they won't work. Everything in life in AS 1851 needs to be maintained at certain periods throughout the year. And that includes wardens. Wardens actually, that's people coming to AS 1851, and that then leads you to AS 3745 to have maintenance on you every 6 months and a trial evacuation for a building every 12 months. So is the smoke management system able to maintain the base of a smoke level at design height? The design height is what engineers put into their computer. So they're saying, right, well, we've got a fire here. We've got a table. It's made of this type of wood. It's got some matting on it. It's got some chairs around it, plastic, and it's caught fire. How much smoke is produced? How high is the flame? Etc. Etc. It just goes on and on and on. So will that ensure the safe evacuation of people? So has anyone got any questions on that? Like I say, it's absolutely a massive, massive subject. There's some YouTube things there. There's some more flashover demonstrations and what have you. If you want to watch them, you can go on and you can have a look on the web if you're interested to see what sort of equations engineers use to work out smoke layers, work out temperatures, all that type of thing. So as I say, it is a massive, massive subject. So next time, in about 2 weeks' time, or might be next week, because this might be a bit close to my next session, might be 3 weeks even, because I've got a big one coming up with the Fire Protection Authority, which I've got to get going. So we'll talk about then alarm systems, which we're going to do this time, but the reason I didn't is because smoke management systems come into this, and I think everyone knows enough about the smoke detectors, thermal detectors, you know, self-closing fire doors, all that type of thing now. And we talk about the alarm systems, the whole thing that actually controls all of those systems all in one. So any questions? John G? No? Can't hear you.
None from me, mate.
It was actually, John, interesting. Your building next door, 60
Flinders,
which you used to run, that's got smoke barriers in it, which you don't realise. You know, this roof on all the floors, and they've got barriers around. It's got a big atrium going up that building, guys, right? And it's got barriers all the way around. Well, what they didn't do, you know, they didn't put ceiling tiles in. What they did was made that bit beyond the ceiling tiles, that is a smoke containment zone. So it looks like the Unfinished Symphony, but it's not, John. It's actually to contain smoke in that area.
No, very well planned.
Did you know that? So that's why you've got all the wires and everything exposed there. Anything else, guys? No? Jason? No?
That was excellent, Nick. I really enjoyed that. Thank you.
All right.
Thanks, mate. I'm going to have to go.
I'll put it on. Yeah, right. I'll put it on our.
Hey, John.
See you, John. I'll put it on our. What you call it for everyone else to look at anyway, as usual. Okay, with the slide. The slides actually have got a lot of notes on the pages this time. Remember, before I've been putting I don't like putting lots of words on slides. The reason I did it because I knew I was handing it around to people. But now what I've done, I've gone to the notes on pages and tried to reduce the amount of words on the slides. All right. If anyone wants to see further, like I say, it's a massive, massive subject. And I think all people need to know is, yes, there's noise in buildings. It's designed to take smoke away. to keep the smoke layer level right and to keep the temperature right. And to get to that stage, there's lots of mathematical equations. It's not as simple as just putting a fan on the ceiling and getting rid of the smoke. It's got to be well worked out, and it's got to be maintained as well. All righty.
Excellent.
All right, guys. Thanks for that. And
Thanks, Nick. Appreciate that.
And I'll see you later.
See ya.
Cheers, Jason.